A functional group is a group of atoms and bonds that possess a predictable chemical behavior. So we're going to cover the most common functional groups that you will see in a college organic chemistry class. And you can kind of group them into three categories. The first category will have carbon with multiple bonds. So carbon with multiple bonds. Let's look at an example where carbon has more than one bond. Well, if carbon is bonded to one other carbon atom, we've already referred to this as an alkene. And if I were to complete my dot structure over here, I would know that I need two more bonds on my carbons, like that. And those could be connected to just about anything. So we're going to put an R group in here to represent the fact that there could be just about anything attached to those carbons. And R stands for the rest of the molecule, or the remainder of the molecule. So usually we're talking about, carbons and hydrogens here, but it could be one carbon, two carbons, five carbons. It doesn't really matter. It just allows us to focus in on the alkene functional group. So if I were to draw an example of an alkene, I could put my double bond in here, and then on either side of my double bond, I could put just about anything, right? So I could put a hydrogen right here, and I could put, a methyl group right here, and then over on this side, I could put, an ethyl group, and on this side I could put a hydrogen. Okay, so that's an alkene, and I could have drawn lots of different R groups and created lots of different looking alkenes, but they're all alkenes, and they will all react in similar ways. Let's do another example. This time, instead of carbon double bonded to another carbon, let's do carbon triple bonded to another carbon, like that. So we have an R group on either side of my carbons here, like that. So this is called an alkyne. So if you see a triple bond, think alkyne. Examples of an alkyne. Let's do one. Let's put our triple bond in there. And again, I could put just about anything on either side of my triple bond. I'm going to put a methyl group on either side, like that. So that's one alkyne that you could have drawn. And finally, our last example of carbon with multiple bonds. All right, we're going to start with a ring here, and then in that ring, we're going to put some double bonds. And so this is not an alkene. Even though I have three double bonds in the molecule, this ring is referred to as an aromatic ring. All right, so an aromatic ring, also called an arene. So arene probably comes from the fact that it's aromatic and it has double bonds in it, so it's an arene for alkene there. So an example of an aromatic ring, the simplest example would be just that aromatic ring by itself. That is called a benzene ring. I could put a methyl group coming off my benzene ring and call that methylbenzene, which is otherwise known as toluene. So that takes care of my first category of functional groups. And let's look at my second category here. So my second category for functional groups is where carbon is bonded to an electronegative atom. So these are very loose categories, right? So it doesn't have to be exactly that way, but pretty much everything in this category will be carbon singly bonded to an electronegative atom. So if I look at an R group that contains a carbon, I say that carbon is bonded to an electronegative atom of nitrogen, right? And I know that nitrogen could have this sort of structure around it, since nitrogen has 5 valence electrons. This is called an amine. All right, so an amine due to the presence of that nitrogen there. So let's draw a picture of an amine. All right, so I could put nitrogen in the center here, and I could put 2 ethyl groups coming off of it, and then a hydrogen. So this is diethylamine. All right, well, what about instead of nitrogen, if I had a carbon bonded to an oxygen, like that? So then there's an H over here. We've seen this one before. This is an alcohol functional group. So lots of examples of alcohols. The one that we talked about before was ethanol, right? 2 carbons, and then an oxygen, and then a hydrogen. Well, if I took off this hydrogen here and I put an R group instead of that hydrogen, I would get another functional group. So let's see what we have if we replace that hydrogen with an R group. So let me go ahead and put an R group in here. This is called an ether functional group. So I had a student one time tell me a good way to remember an ether functional group. She said, just remember that there is an R group on either side of the oxygen. So I apologize for the bad pun, but if it helps you remember it, it's worth it. So here I have my oxygen, and I'm going to put an R group on either side. I'm going to put an ethyl group on either side of my oxygen. So that's diethyl ether, which some students think that dot structure looks a little bit like a bird. So I can replace the oxygen with a sulfur. Sulfur is in the same group as oxygen on the periodic table, so sulfur will react in similar ways to oxygen. So if I replace the oxygen in an alcohol with a sulfur, I no longer have an alcohol. I have what we call a thiol functional group. So a thiol functional group, and I could have a 2-carbon thiol, which we would call ethane thiol. Just like before, I can replace this hydrogen here with an R group and get yet another functional group. So if I replace that hydrogen with an R group, I get a sulfide functional group. So a sulfide. And if I have sulfur in the center here, right, I could put an R group on either side like that. So that's diethyl sulfide. And finally, my last functional group in this category, I could have a carbon and an R group singly bonded to a halogen, right? So halogen could be any of the elements in group 7 that we discussed, right? So chlorine or fluorine or bromine. This functional group is called an alkyl halide, right? So that could be any halogen. So I'll just choose chlorine as my halogen, and this molecule is one that's important in organic lab a lot of the time. This is called a tert-butyl chloride. Let's move on to our third and final category of functional groups. So here we have our third category of functional groups. And all of the functional groups in this category will have carbon double bonded to an oxygen, which we call a carbonyl group. So look for the carbonyl groups in all of the remaining functional groups that we will draw here. So if I have an R group bonded to a carbon, double bonded to an oxygen, and then I put a hydrogen on this side, I can see there's a carbonyl in this functional group, right? C double bonded to an oxygen. And when that carbonyl carbon is bonded to one R group and one hydrogen, we call this an aldehyde. So an aldehyde, the name comes from alcohol dehydrogenated. So let's draw an example of an aldehyde. So something like this, right? And even this other R group could be a hydrogen. That would make the molecule formaldehyde. So this is an example of an aldehyde called butanal. All right. If I replace this hydrogen here with an R group, I get another functional group that contains a carbonyl. So there's my carbonyl, and I'm going to put an R group there, right? So something containing carbon. This is a ketone. So let's draw a picture of a ketone and compare it to an aldehyde, because students sometimes have a hard time telling these guys apart. So this is butanone as my ketone. And if I look at these two molecules, I can see here's my carbonyl, and if my carbonyl is next to a hydrogen, at least one hydrogen, that is an aldehyde functional group. If I take this ketone here, there's my carbonyl, and that's bonded to two different R groups, right? So that is the difference between an aldehyde and a ketone, and you need to make sure you understand that difference very well. All right, another functional group that contains a carbonyl. So here is my carbonyl, like this, and I'm going to put a nitrogen directly attached to my carbonyl this time. So this represents an amide functional group. So let's draw a picture of an amide functional group. All right, so there's my carbonyl, and my nitrogen directly bonded to my carbonyl, so that is butanamide. And students sometimes have a hard time telling the difference between an amide and an amine. An amide is when you have a nitrogen next to a carbonyl. So if it's next door to it, it is an amide. If that carbonyl weren't there at all, then we would have an amine. So I think that's where sometimes the confusion sets in for students, right? So look for that carbonyl to identify an amide. All right. So instead of nitrogen, let's bond our carbonyl carbon to an oxygen atom like that. So this functional group is called a carboxylic acid. So carboxylic acid, one of the most misspelled words I see on tests. All right, so that's carboxylic acid. An example of a carboxylic acid, well, one that I think everyone has heard of before. If I draw a carboxylic acid like that, that is acetic acid. Derivatives of carboxylic acids. If I take off this hydrogen and I put an R group, I get another functional group. So I have an R group instead of that hydrogen. This is called an ester. All right, so let's draw a picture of an ester here. So an ester looks something like that, and that is ethyl acetate. So you can see now there's an R group here instead of this hydrogen. All right, another derivative of a carboxylic acid, right? I could replace that R group on my ester. I could replace that with another carbonyl. So let's take a look at what that would look like. So I'm going to put a carbonyl there instead of my R group. So something like that. This is called an anhydride. So anhydride. The most common anhydride, the one that you will use in organic lab, to make aspirin. I'm going to draw it like that. That is acetic anhydride, like that. And finally, our last functional group that we will study is where you have a carbonyl, and directly bonded to that carbonyl carbon is a halogen. So I'm going to put an X there for my halogen. This is called an acyl halide. Right, so acyl halide. So let me just draw a quick example of that, and I will put a chlorine directly bonded to a carbonyl. So those are the most common functional groups that you will see in an orgo class, and I think we did about 16, and there are actually a lot more than that. But these are the ones that we will study all of the reactions for.